Hello everyone, welcome to lesson 5-7, distance on the coordinate plane. In this lesson we will continue to apply algebraic concepts to solve geometric problems, and we will use the distance formula. Let's look at a real world problem, mountain biking. Evan was biking on a trail. A map of the trail is shown. His brother timed his ride from point A to point B. So here's point A to point B. Clearly it's not a perfect line, but we could get a good estimate of this distance if we lay down a grid and we make straight legs. So we have our run and we have a rise, okay? And we know that the sum of both legs squared will give us our hypotenuse, right? What do the blue and red lines on the graph represent? The blue lines represent the horizontal and the vertical distances between the 2 points. So here we go. Horizontal and vertical distances between these 2 points. The red line represents the actual distance between the 2 points. So there we go, the actual distance, the hypotenuse. Question 2. What type of triangle is formed by the lines? Well, since we have a perfectly horizontal line here and a perfectly perpendicular line there, we know that this is a right triangle. Question 3. How can you find the length of line AC and line BC without counting the number of units? So line AC and line BC without counting the number of units. Well, we have been given coordinates, right? So what we could do is just simply find the difference between the coordinates. So I have 3 here and a 7 here. What's the difference between 3 and 7? We have 4, right? Is that 4? 1, 2, 3, 4. Yeah. And then over here we have a 4 and a 4. Is there a difference? No difference, right? Because it's flat. It's a horizontal line. Over here, we find the difference for B and C. We find the difference between 7 and 7. Is there a difference? No. 9.5 and 4, there is a difference of 5.5, right? Halfway through the next one without having to count. So what do? We subtract the x coordinates and subtract the y coordinates. In other words, we find their differences. So we can do the difference of y2 minus y1 and the difference of x2 minus x1. What are the lengths of the 2 blue lines? So line AC, which we know is right here, is the horizontal line, AC, and line BC, which is the vertical line. What are their differences? Well, when we did the quick math that we did together, we found that here we have 4 units, right? And then over here we have, for BC, we have 5.5 units, 5.5 units. We did that already together. Number 5, write an equation using Pythagorean theorem that you can use to find the length of AB, to find our, we already know then that one line measures 4, right? And we can make it, that's our A, so that's 4 squared, or we can say A squared plus B squared equals C squared, right? And we can replace those variables with 4 squared plus 5.5 squared equals our C squared, which is our red line, our hypotenuse, okay? You can use Pythagorean theorem to find the distance between 2 points on the coordinate plane. Anytime, as long as you can make a right angle triangle, you can find it. So here's the coordinate plane. And we have this vertical angle here. No, not vertical angle, sorry. It looks almost to be, it's a slanted angle. I'm not sure, can tell you exactly how much it is, but it almost looks to be like 45. And I say that because it's cutting right through this square from corner to corner, almost. So we have this angle here. What we can do is draw a line perfectly vertically and perfectly horizontal to the points where they meet, We identify the length simply by comparing our x-axis, our x coordinates. Okay, as we can see here, we have a difference of 4, 1, 2, 3, 4, where this point is. This would be 1, 2, 3, so 3 and 7. What is the difference between 3 and 7? It would be 4. And what is the difference between negative, well, this is 1, 2, 3, 4, 5, 5. Negative 5 and 0 would be 5. So there we go, we have a distance of 5 and a 4. We replace them. 4 squared plus 5 squared equals c squared, and we solve. And this line is about 6.4. Okay, 6.4 units. Let's try this on our own. Here we go. We have two coordinates, and we need to find the distance between these coordinates. First, we graph it, right? So 1 and 3. We run before we rise. We go to 1 and 3 right there. And we have negative 2, 4, right? As you see there, negative 2, 4. So we're looking for this distance. Here we can make a right angle triangle by drawing a perfectly horizontal line here and a vertical line there. So we get a line that looks like this. I've taken the liberty to draw the legs blue and my hypotenuse red. Okay, and now we have a measurement of 3 right here, 3 units, and 1 unit there. Okay, so we can go ahead now and solve, where we use our a squared plus b squared equals c squared, replacing a squared with 1 squared plus 3 squared equals c squared, and we have 1, because 1 times 1 is 1, plus 9, 3 times 3 is 9, equals c squared, and we get 10 equals c squared. Or I'll just do it right here. I'll cut one step and just take away the square and square root of 10, and I get 3.16, about 3.16, because it goes to, I don't know, 21st decimal place or something like that. If I round that to the nearest tenth, it becomes 3.2 units. And that is the approximate length of our hypotenuse. Let's take a look at our second key concept, the distance formula. In symbols, the distance d between 2 points with coordinates x1, y1, and x2, y2 is given by the formula distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the difference of the x's and the difference of the y's, squared each number. Once we have that, right, we add up those two values and we square it up, and that's our distance. Okay, so essentially it's really no different than what we've been doing. If I could remind you that our d would be our c squared, but now it's only c because we're already squaring off this side. And our x2 minus x1 squared is our a squared, isn't it? And our y2 minus y1 is our b squared, right? And because we're not writing the square root on this side, okay, the power of 2, we square off this side. So it's essentially the same as a squared plus b squared equals c squared. We've just rearranged it and written it as a distance formula. Okay? You can also use the distance formula to find distance between 2 points on the coordinate plane. You can use the model from the key concept box to see how the distance formula is based on the Pythagorean theorem as shown below. Essentially, I just explained this to you, where c squared equals a squared plus b squared, or as we've written it in class, a squared plus b squared equals c squared. It's the same thing, we just flipped it around a little. But you notice that the a squared, we have to look for a value of a by finding the difference of both x coordinates, and we have to find our b by finding the difference of both our y coordinates, and they're still squared. But then in order to get rid of the power exponent here, the square exponent, we have to square off our set of coordinates, right? So that's how it's based. It's based on the Pythagorean theorem. So there we go. Here is two methods. One where we continue to use the Pythagorean theorem, and two where we use the distance formula. Please pause the video and use this time to analyze both of these. And perhaps you can choose one that you think you'd like to use more. Some of you might just want to continue to use the Pythagorean theorem, and some of you might want to use the distance formula, seeing as this is a formula that works exactly the same way and could help you in a different context. Okay, pause the video now. Question B. If you think you'd like to try this on your own, please pause the video now, try it on your own and see how you do. Okay, pause now. You can see here, everyone, that I've already started by writing down my equation. Okay, we have Cromwell Field is located at 2.5 or 2.5 and 3.5, and Deducts Field at 1.5 and 4.5 on a map. If each map unit is 0.1 mile, about how far apart are the fields? Okay, so each map unit is 0.1 of a mile, 1/10 of a mile. So what do we have to do? Let's find the differences between our coordinates. Okay, I'm going to go ahead and replace my variables where I have here my x1 and my y1. Okay, and over here I have my x2 and my y2 right there. So I'll go ahead and replace these coordinates in here. So first you can see that I'm replacing my y1 and my x1 and my y1 here, right? x1 and y1. Okay, and now I'm going to bring down my x2 and y2, and I color-coded them blue. So now I have 1.5 here and 4.5 here. Okay, and I can start solving where I write my c equals square root of 1.5 minus 2.5 squared, negative 1, okay, plus 4.5 minus 3.5 is positive 1 squared. Now I will solve with my square roots, right? So c equals square root of 1, negative 1 times negative 1 is simply 1, plus 1 times 1 right here, positive 1 times 1 is also just simply 1. So now I'm looking for the square root of 2, right, when I add them. The square root of 2 is about 1.4. Sorry, I should put that as about, so I'll rewrite that as about 1.4. Now, they're telling me that if each map unit is 1/10 of a mile, so I have to take that in consideration. It's not actually 1.4. If each map unit, I have 1.4 units here on the map, but each one of these is only worth 1/10. So if it's only worth 1/10, I actually have to write it as in the format of 1/10, where I actually have the distance here. Okay, my distance is, or actually I could write distance is approximately 0.14 miles. That's the complete answer, seeing as each unit is 1/10 of a mile, and I have 1.4. How many 1/10 do I have here? It's like saying this is $1.40. Now I'm changing into money, but this is $1.40. How many 10 cents do I have here? Okay, I had 14 of them, but in terms of miles, it's 0.14 miles. Example 3. Use the distance formula to find distance between our x and our y round to the nearest 10. Now, this is not our x-coordinate, this is our point x on the graph and our point y on the graph, and we want to find the distance between the two. So again, we use the formula where we find the difference between our x's, so x2 minus x1, y2 minus y1, as you can see here. We find the difference, we square root it, we find it to the power of 2, we add them, and then we square root the value. So the distance, as you can see here, it's all follow, you can follow the steps here, explained. The distance of xy, or line xy, or point xy, is approximately 8.2 units. I'm not sure what the units are, if they're miles, centimeters, who knows. Okay, so substitute the values for x2 and x1, as you see here, and substitute the values for y2 and y1, as you see here, into the distance formula, and then just simplify it, as you already know how to do. Here is our guided practice. We will look at this in class tomorrow. You can see it's only 2 questions. Make sure you feel comfortable with the content. If you don't, go back to the example or simply ask in class. See you then, everyone.